Hi, Sue here, and today I'm going to be talking about this amazing toy. It's called a Wandarama, and I love it. So it's going to be using forces, electric forces, for us to do some kind of really cool magical demos. In the kit, there's the wand. I've also put in some packing peanuts because they're quite difficult for us to find at home. You'll find one tin foil. The job for you is then to eat the pies and the cakes to get the rest. I've put in some modelling balloons. The children or yourselves will enjoy kind of making some crazy balloon creatures, but balloons, as you'll find out, are also a very, very good source of static electricity. You've got nice little stickers so you can decorate your wand. And then there's also a booklet which has got a whole range of very, very fine metallic mylar shapes. So some of them are small butterflies, big butterflies, and the others you're going to see me playing with. And last but not least is teaching notes. So you're going to find there will be teaching notes with quite a lot of the gadgets that I am selling. And the very first page of these teaching notes has got a little diagram that shows you what the inside of this very small Van de Graaff machine, Wandarama, which means you don't have to pull it apart to be able to see what's going inside. There's a nice little diagram there. So I'm going to put all of these out today, and we're just going to start playing. Now, we are using static electricity, so if the weather is very humid, if it's raining and the gadget isn't working as well as you would like it to do, then a hairdryer. So in my physics lab, I would use a hairdryer on the larger Van de Graaff machine, and using a hairdryer or putting it on the radiator to dry it out, and then all of a sudden you'll find it's going to be working perfectly again. So I'm going to move this again out of the way so I can then have lots of room to play. Now, inside here are two plastic rollers, and when I press this button, the electrical voltage will give a push on the motor, and I will be able to get a motor to get a rubber band to move over those rollers. So basically, I've got two insulating materials being rubbed against each other. And I can do exactly the same using a balloon and my hair. And when I do this, we're able to steal the outer electrons from the atoms, and one material will donate them and the other one will accept them. So you'll end up with one material being positively charged and the other negatively charged. Bit noisy, this. And then we find out that these charges, negative and positive, pull together. And so the further I move that force field away, then the weaker the force is. So as I bring the balloon close to my hair, there's a big pulling force, and as I move it away, that force weakens and gravity will pull my hair back down again. So just like gravity, an electric force field is strong when the charges are close together, and as we move the charges apart, that force field gets weaker and weaker. So one of the main reasons I put balloons in the bag is so that we can rub them on our hair, and you can go to the shops and get the round ones, etc. So let's kind of have a look at this wand. So this is charging up. I'm going to play with one of the smaller mylar shapes. So when I let it go, gravity is going to pull it down. But if I touch it with the wand, look at that, it's amazing. And I've now got it hovering in the air. And for it to do that, there has to be forces in action. So I've got a weight force acting down, and that's due to the small mass of this mylar shape and gravity pulling it down. And then I've got an upward pushing force, the electric force, due to this being electrically charged and this object having exactly the same type of charge on it. Now I let that fall due to gravity, and then I can bring it in a larger shape. So again, the further this is away, the weaker the force. As it gets closer, the stronger the force. So we have to kind of understand, why is this being pulled together? And so we have to then go back to this idea of everything being made up with the atoms. Now inside the atom, we've got a positive particle, it's fixed, it can't move. But on the outside, we have electrons, and those electrons can move. In metallic objects, they move very easily, and we need to put bigger pushing forces on them to get them to move for materials which hold on to the electrons a little bit stronger. Now, the electrons, if this is negatively charged, any of the electrons that's on the surface here are going to be pushed away from it. And if they're pushed away, that's going to leave this end positively charged, and positive and negative pull together. And when this touches then because of this is made from metal, all of the charges will move, and these two items will have the same charge. So opposite charges, they pull, and if they're the same charges, we can get them to push. And again, I can get it to, change shape. I can get it to start moving, stop moving, speed up, slow down. All of those kind of wonderful force actions that we have going. So that's going to be loads and loads and loads of fun. There's only one wand in the pack, but don't worry, because somebody else can be charging up balloons, because there's lots of these different mylars in there, mylar shapes. And again, look, it's pulling in. I let it drop, and I got attacked there a little bit, so let's do that again. Obviously a lot easier if you're standing up. So I've got that frictional force going on. My hair, yeah, it's definitely being charged up. Let's move this a little bit further away from my face, and and then hopefully we can get this to charge. Now, this is just letting us know that it does take a little bit of practice, so don't worry if you don't get it first time. It's a little bit sneaky, so once it touches, we have to kind of give it a little jerk movement, and there we go. And now I can use that to get it to fly as well. So it's not just as easy with the balloons to get it to fly as it is with the wand, but unfortunately, you have to get the wand to get these beautiful, amazing shapes. So what else can we do with the wand? Well, this is why I've kind of put in these packing peanuts. Not all of us will have these packing peanuts at home. They're biodegradable. You can get polystyrene ones which are not biodegradable. And again, just with the mylars, when I bring the charged object close to them, something weird's going to happen with the electrons. And that means we're going to be able to get pulling forces. And I can kind of get a nice little kind of design going on there with these pulling forces. You can try Rice Krispies, or can I get 3 standing up on end, or maybe not. So the tin foil, what I've done is I've made a sleeve out of a sheet of A4 paper, and just using sellotape I've got it to stick on there, and that means I can stick these dudes in there. Now remember, with the mylar shapes, whenever they were touching, they got the same electric charge. So these will get charged up the same as this wand, and therefore they will push and they'll jump out like, I don't know, people jumping ship. So we'll get rid of those. How big is this force? Well, I've eaten lots of pies to be able to do this experiment. These are much heavier than those little shapes. So let's push that down. And my hand's shaking there. Nothing's really working. So this is where we're going to give that little tip again. If it is very, very damp, lots of humidity, then that's due to the fact we've got lots of water in the air. Water molecules are charged in the way that one part is positive, one part is negative. Not all the molecules do that. We call it a dipolar molecule. I nearly forgot the word there for a moment. And so the hydrogen atoms, that they give their electrons to the oxygen. They spend most of their time in the oxygen. So we end up with the hydrogen atoms being positive and the oxygen atom being negative. And anything charged, they come by and they steal those charges. So let's kind of heat this up just a little bit and see if we can kind of get rid of some of that heat. Get rid of the water, rather. So I'm not sure how long we need to do this for. Obviously, if I was skilled in the whole video thing, I'd be able to, and this is what I did earlier. So we've dried that off. Let's see what happens. And da 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 da. They are now flying. So don't worry if it doesn't work first off. It's most probably due to the fact that there's a little bit of moisture in the air. Use your hairdryer, dry it off, and everything is fine. So the last little trick that I'm going to do is using this as a sheet, as some glue. So I'm going to get a sheet of paper here, and when I put it onto this piece of cardboard, gravity is going to kind of pull it off. So what we're going to do here is we're going to apply an invisible glue to the paper. And if I just rub that over there like that, and then, oh, da-da, So at the end of the notes, I'll explain a little bit how we use static electricity in engineering and everyday life experiences. So this amazing gadget is a toy, but it can be used to teach some amazing science about electricity. It's called a Wandarama. Thank you so much for watching.